Okay, so now we're going to do practice D, which is conservation of energy. And this is problem 6 through 10. All right, so let's look at number 6. Number 6, we're going to write our given, and we're going to write our find. So it says an 8-kilogram flower pot falls from a window ledge 12 meters above the sidewalk. What is the kinetic energy of the pot just before it reaches the sidewalk? Using energy considerations only, find the speed. So remember, here's our flower pot, and it's falling to the ground. The total energy here is the total energy here. At the top, when it's at rest, this is going to be all potential energy. As it falls and gets closer to the ground, whatever I lose in potential, I'm going to gain in kinetic and vice versa. But what I'm going to do to solve this is I'm going to write my conservation of energy. So I'm going to say the total energy before is equal to the total energy after. So my total energy is a sum of the potential and kinetic. So I'll say PEI plus KEI is equal to PEF plus KEF. So the initial potential energy, and again, what you can do is you can have stuff go to 0 now, or just write it all out and have stuff go to 0. So again, this is going to be MGHI plus 1/2 MVI squared is equal to MGHF plus 1/2 MVF squared. Okay. Now we want to save ourselves time. Initially, the kinetic energy is 0 because the velocity is 0. At the end, we measure energy from the ground, which we call base level. So because the height is 0, this is also 0. Okay. Now instead of even plugging this in, so I can have MGHI, I want to solve for KEF is going to be equal to KEF. So that's going to be 8 kilograms times 9.8 meters per second squared times 12 meters. And when I do that on my calculator, it comes out to be 941 joules. And remember, a kilogram meter per second squared is a newton, and a newton times a meter is a joule. All right, part B says what is the final velocity? Where I know that kinetic energy is 1/2 mv squared. So the final kinetic energy, which I just solved for, is 1/2 mvf squared. So I'm going to not plug numbers in. That's why I make a mistake. I'm going to rearrange the equation to solve for the unknown in terms of the known. So what I'll do is I'll multiply both sides by 2. So I'll have 2 KEF is equal to mvf squared. I'll divide by m. So 2 KEF over m is equal to vf squared. And then I'll take the square root of both sides. So I'll have vf is equal to the square root of 2 KEF over m. I'll substitute in my values. 2 times 941 joules divided by 8 kilograms. And remember, I don't want to forget to take the square root. So this is 15.3 meters per second. And how do I get meters per second? Remember, my units are under the radical. So a joule is a newton times a meter divided by a kilogram. But that's also going to be a kilogram meter per second squared times a meter divided by a kilogram. Okay? So the kilograms cancel. A meter times a meter is a meter squared. So I end up with meter squared over second squared. So when I take the square root of the number, I take the square root of the unit, and I get my correct unit, meter per second. And then I see I did not make an algebra mistake. I have a foolproof way to always check my work in physics. All right, let's look at number 9. So number 9, I have my given, and I have my find. And I'm going to read the problem. It says, during a hammer throw at a track meet, an 8-kilogram hammer is accidentally thrown straight up. If 784 joules of work were done on the hammer to give it the velocity, how far will it rise? So again, we know that potential energy is equal to mgh. And we know the work is equal to the change in energy, which is equal to FD. So basically, I'm going to have mgh is equal to FD. I want to solve for h, so I'm going to move this to the other side. I'm going to have h is FD over mg. Well, FD is the work, which I already know. I didn't have to write FD. So that's going to be 784 joules divided by 8 kilograms times 9.8 meters per second squared. And a kilogram meter per second squared is a newton. So remember, this is a newton times a meter. This is a newton. They cancel out. I'm going to get meters, which is my correct unit. And when I do this on my calculator, the height comes out to be 10 meters. That's it.